Hello students, so welcome back to the channel. So today we'll be trying to see, or today we'll be going to for the next subject, so that is strength of materials. So this is there for DCET 14 marks, so that is allotted in the syllabus. So strength of materials and the engineering mechanics. So the subject is like this: engineering mechanics and strength of materials. So that is the subject related, or which is consisting of 14 marks. All the concepts will be covered in the video lecture, and as we move on with the topics, we shall also see some of the objective type questions, how it will be asked and how it will be taken up by it. So today, first and foremost, so we shall try to we shall see the introduction part of the strength of materials. So what are strength of materials, what is engineering mechanics and all, we shall try to see here. So what is the mechanics? So first and foremost, we shall see the basics, that is what is mechanics. So mechanics is a subject. So it is a branch of science which deals with a body which is under the rest or which is under the motion. So mechanic means the body is dealing under the motion or the static. So there are two concepts, one is static and one more is dynamic. So this is the mechanics dealing with static as well as with the dynamic. The body which is under the rest and the body which is under the motion. So ಇವು ಎರಡು ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಕಲಿಲಿಕ್ಕೆ ನಮಗೇನ್ ಬೇಕ್ರಿ, ಮೆಕ್ಯಾನಿಕ್ಸ್ ಅನ್ನ ಕಲಿಬೇಕಾಗುತ್ತೆ. ಸೊ ನಾವು ಡೆಫಿನೇಷನ್ ಆಫ್ ಸ್ಟ್ಯಾಟಿಕ್ ಹೇಳಬೇಕಂದ್ರೆ, ಸೊ ಇಟ್ ಈಸ್ ಅ ಬ್ರಾಂಚ್ ಆಫ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ which dealing with the body which is under the rest. So motion or the dynamics, it's a branch of mechanics which deals the body under the motion. So these are the definition. So in the DCET exam, they might ask you a simple definition and they shall give you the 4 options. So that is nothing but the mechanics. So in mechanics nalli first and foremost barodhu ಏನು ಗೊತ್ತಾ, so it is force, which is very important quantity. Force is nothing but, so it is an external quantity. External quantity ಅಂತಂತಂದ್ರೆ ಹೊರಗಡೆಯಿಂದ ಅಪ್ಲೈ ಆಗುವಂತಹ ಒಂದು ಕ್ವಾಂಟಿಟಿ. ಯಾವುದೇ ಒಂದು ಬಾಡಿ ಮೇಲೆ ಎಕ್ಸ್ಟರ್ನಲಿ ಅಪ್ಲೈ, ಹೊರಗಡೆಯಿಂದ ಒಂದು ಅಪ್ಲೈ ಆದರೆ ಸೊ ಬಾಡಿ ಏನಾಗುತ್ತೆ, ಮೂವ್ ಆಗಕ್ಕೆ ಶುರು ಆಗುತ್ತೆ. ಸೊ ಮೂವ್ ಅಂತಂತಂದ್ರೆ ಸೊ ಚೇಂಜಸ್ ಇಟ್ಸ್ ಪೊಸಿಷನ್. ಮೂವ್ ಇನ್ ದ ಸೆನ್ಸ್ ಇಸ್ ವಾಟ್, ಚೇಂಜ್ ಇಟ್ಸ್ ಪೊಸಿಷನ್ ಫ್ರಮ್ ಒನ್ ಪ್ಲೇಸ್ ಟು another place. So that is nothing but the force. Technically speaking, so when applied force on a body changes its state of rest. Rest intra motion ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡುವಂತಹ ಕ್ವಾಂಟಿಟಿಗೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ, ಫೋರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. So what is a force? It is an external quantity when applied on the body. So always it will be applied on the body, converts from rest to motion. So this is nothing but the force. So what is the unit of force? So unit of force is Newton. So this is very important. So unit of a force is Newton. So Newton is a unit, and we can also write it as 1 kilo Newton is equal to 1000 Newton. So this is the main and unit of force. So 1 mega Newton is equal to 6 Newton. So this implies 10 raised to 3 Newton. This implies 10 raised to 6 Newton. 1 giga Newton is nothing but total 9. This implies 10 to the power of 9. So these are some of the concepts that will be asked in the DCET. What is 1 mega Newton, 1 kilo Newton, 1 giga Newton? That is very important in the mechanics. So force is that type of quantity which has, it is a vector quantity. So first and foremost, force is a vector quantity. That means it has both magnitude and direction. So both it will be given. So in the sense, so if I want to represent the force, for example, there is a body now. If I apply the force of 10 Newton, so 10 is the magnitude. In which direction I am applying, that is important. So that's why it's a vector quantity. Second, the line of action. Line of action. Line of action means whatever the force I apply, in that direction only the body will try to move. If I apply in this direction, the body will try to move in this direction. So that is line of action. Third one, point of application. Point of application. At what point I am applying the force? For example, I have applied the point of force is here. If I can apply the point here also, I can apply the point here also. So that is the point of application. So these are nothing but characteristics of force. So this is very, very important. So characteristics of force, vector quantity, line of action, point of application. So the very, very important. So mechanics dealing with static and dynamic. Okay. Next is the force. The force is related with some units and the characteristics. So these are the main basic concepts. So next one we have the moment and couple. So what is a moment and what is a couple? Moment is nothing but the force applied on a body at a perpendicular distance. So force is related to moment also. So it is, both are almost same, but here we are introducing some distances. So how it is done? See, for example, there is a body. There is a body in which here it is fixed. And if I stand on this body, so what happens? The total weight of the body is applied. So what happens? The weight acts on this wooden plank. This is a wooden plank. This is a wooden plank. So when the weight acts on this wooden plank, this plank tries to bend like this. So the force applied at some distance L. So therefore I can write it as moment is nothing but the force, whatever the force that is applied into perpendicular distance L. So I can write it as moment is nothing but force into distance. So that is nothing but perpendicular distance. Perpendicular distance. I can give an example. Example of a door swinging. Door swinging is one of the best example. If I want to swing the door, so I need to apply one side force and another side it is hinged. So that is the moment. Coming to the couple. So couple is nothing but two forces which are applied on opposite direction. So this is plus force and this is minus force, separated by some distance, that is perpendicular distance. So these two forces should be perpendicular with some distance d. One force is moving in positive direction, one force is moving in negative direction. Both should be in opposite. It cannot be like this. Two forces are moving in same direction. To form a couple, compulsory you require two forces which are in opposite direction so that it rotates. For an example, your cycle pedal. So cycle pedal, you need to apply two forces in opposite direction so that you will get the rotation effect. So that is nothing but the couple. So coming to this moment, what is the unit of moment? So unit of force is Newton and unit of length is meter. So therefore, so unit stands is Newton meter, or I can write it as Newton mm, or I can write it as kilonewton meter also. So this is the unit of moment. Okay, and the same also goes with the couple as well. So next is, that is stress and strain. So which is very, very important here again. So what is a stress and what is a strain? For an example, there is a body which is sitting over the ground. There's a body sitting over the ground, and here when we apply the force, if I apply the force F, there is an internal force, that is set up here. This internal force or internal resistance is nothing but the stress. So you need to understand very carefully, that is internal resistance. For an example, if somebody tries to push me, I shall bend, but to resist it, I shall come forward. The inside force that comes out, or the reaction force that comes out, is nothing but the stress. So how it is defined? So stress is defined as sigma. So this is denotion, or the denotion of the stress. So stress is nothing but force per unit area. Now how I shall show you in the strength of material. For an example, now just refer the, so this is a bar which is having a length of L, which is having a breadth B and a depth D. So this is length L, bar, B and D. So this is the cross section of the bar. Now what I will do, I will apply the force in this direction. This is the force applied, and this is the area that is there. So this is the force here. So what about the area? Area is nothing but B into D. So what happens if I apply the force? If for example this is the bar, if I stretch this bar, so it elongates. So what happens to the length? The length gets increased. So this increase in length is nothing but the change in length. So this I can write it as change in length. So delta L stands for change in length. Now coming to the unit, which is very, very important in the stress. So what is the unit of force? It is Newton, and area unit is mm square. So unit of force is Newton per mm square, or I can write it as kilonewton per meter square also. So these are the main units I need to remember. So in the DCET questions, they might ask you the unit of stress is dash. So 4 options will be given. You need to pick it the exact unit. Now next, coming to the strain. So what is a strain? Strain is nothing but change or deformation in the body. Rate of change of deformation in the body. So what happens sometimes, now for example, now you can see the illustration. So this is the car that is going to come, and there is one more car that is going to come. Both of them get collided, and both of them will be having some forces, and both of them will be having a resistance also. That resistance is the stress. Now what happens, both of them if they collide, ಎರಡು dash ಹೊಡೆದು ಬಂದ್ರಿ ಏನಾಗುತ್ತೆ? So what happens, the body tries to bend, or the body tries to crush, or the body tries to crush, the body tries to elongate, or it might come in the less, or what happens is the body tries to bend in any direction. So that bend, or whatever the crush it happens, that is nothing but the strain. So that is nothing but rate of change of deformation. So that is given by epsilon. Epsilon is nothing but change in length divided by the original length. So how it is calculated? Now for example, this is the bar. If I apply the force, what happens? The body tries to increase its length. Original length is this much, but the increased length is this much. What is this much length? That is nothing but the change in length divided by the original length. Now what is the unit of this strain? So unit of strain is delta L. I may measure it as, I will measure it by mm. Length also I will measure it by mm. So both of them will get cancelled. So strain unit is unitless. So you don't have any unit for the deformation. Be careful. This questions might be asked in your DCET, which is very, very important. Now, coming to the next. So, what is actually stress and a strain? What is the relation? This is the big brother. This is the younger brother. So, this is the elder brother and this is the younger brother. So, now what is the relation between them? So, there is a relation between the stress and the strain. So, what happens is, as the stress increase, stress means the force applied. The force as go on and increase, the body tries to change in its shape. So, change in its shape is nothing but the strain. So, strain is nothing but it is directly proportional to strain. So, stress hang increase akonta hoketri, hang strain nu increase akati. Stress increase antandre hang body na jakkonta hogtiri, hang body enaketri elongate akonta hogtiri. So, ಎರಡು ಸಮನಾಗಿರ್ತೈತಿ. ಇದು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ರಿ ಇದು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತೈತಿ. ಇದು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ರಿ ಇದು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತೈತಿ. ಕಡಿಮೆ ಮಾಡ್ರಿ ಇದು ಕಡಿಮೆ ಆಗ್ತೈತಿ. So, to remove this constant of proportionality, I will apply one constant, that is E. That is nothing but epsilon. Now, stress is, I can bring this E. So, this E is nothing but stress by strain. So, E ledri idana E side tombarri. So, what happens? E is nothing but stress by strain. So, Young's modulus, E is nothing but the Young's modulus or modulus of elasticity. Modulus of elasticity. So, E is nothing but stress by strain. So, what is this E? E is nothing but the Young's modulus. So, Young's modulus definition ಏನಂತಂದ್ರೆ, it is the ratio of stress divided by the strain. So, ಇದನ್ನು ಹೇಳಿಕೊಟ್ಟವರು ಯಾರು? There is one person called as Hooke's. So, what is Hooke's law? Hooke's law states that whenever an external forces that is acted on upon a body, or we can say it as stress is directly proportional to strain within the elastic limit. Hooke's law will be within the elastic limit. Be careful. Hooke's law always holds good for the within the elastic limit. I'll tell you once again. Hooke's law states that stress is directly proportional to strain within the elastic limit. So, this is very, very important. So, Hooke's law is limited to dash. That is your DCET question. So, you should take it as elastic limit. So, which is very, very important. So, I hope you people are clear with stress, strain and Young's modulus. So, yes guys, next we will be studying about the material property. So, which are the material property? Elasticity, plasticity, ductility, malleability, hardness, toughness and the strength. So, what is elasticity and plasticity? So, first is elasticity. Elasticity is nothing but it is when the force is applied on a body, it regains its original position. So, that is nothing but elastic. For example, your rubber. So, if you stretch it and if you leave, it come back to its original position. If it doesn't come back, then it is plasticity. So, remember, if it comes back, elasticity. If it doesn't come back, it is plasticity. What is meant by ductility? Ductility is nothing but it can be stretched like a wire. So, that is nothing but the ductility. When a body or the body can be stretched in just like a wires. That is nothing but the ductile material or ductility. What is malleability? Malleability is nothing but it can be rolled into thin sheets. Thin sheets can be rolled over it. So, that is malleability. What about the hardness, strength and toughness? Hardness is nothing but, for an example, if I ask you if this material is hard or not, so you will compulsory say it is a hard material, because if I scratch on this body, I should not get any powder content. So, if I get the powder content, so I cannot say it as a hard material. So, it doesn't come the powder material, then it is a hard material. What is the toughness? If two body comes and hits, so there should be no breakage in the body. There is a toughness. What about the strength? Strength is nothing but it should give resistance to the body. That is nothing but the strength. Now everybody knows that is the stress strain curve. So yes, so this is the stress and this is the strain. So here you can see the stress strain curve. So here you can see the stress strain curve. This stress strain curve is for steel. This curve is for the steel, not for the concrete. So what happens? This is the O point. If I go on increase with the stress, what happens? The stress goes on decreasing. ಹೆಂಗೆ ನಾವು ಬಾಡಿ ಮೇಲೆ ಲೋಡ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ, ಬಾಡಿ ಏನಾಗುತ್ತೆ ರೀ ಸ್ಟ್ರೆಚ್ ಹಾಕೋಂತ ಹೋಗುತ್ತೆ. ಎಲ್ಲಿ ಮಟ ರೀ? ಅಪ್ ಟು ದಿ ಪಾಯಿಂಟ್ ಎ. ಸೊ ಓದಿಂದ ಎ ಮಟ ಹೋದ್ರೆ ನಾನು ಸ್ಟ್ರೆಸ್ ಬಿಟ್ರೆ ಇಲ್ಲ. ಸೊ ನಾನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ ಆಮೇಲೆ ಬಿಟ್ಬಿಟ್ಟ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ ರೀ? ಇಟ್ ಕಮ್ ಬ್ಯಾಕ್ ಟು ಇಟ್ಸ್ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್. ಸೊ ಓ ಟು ಎ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಇಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್. ಇದ್ರ ಮೇಲೆ ನಾನು ಸ್ಟ್ರೆಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ, ಇಫ್ ಐ ಅಪ್ಲೈ ದಿ ಫೋರ್ಸ್ ಅಬೌವ್ ಎ, ಸೊ ಇಟ್ ಗೋಸ್ ಇನ್ ಟು ದಿ ಪ್ಲಾಸ್ಟಿಕ್ ಸ್ಟೇಟ್. ಸೊ ಓ ಟು ಬಿ ಗೋಸ್ ಟು ಪ್ಲಾಸ್ಟಿಕ್ state. It doesn't come back to its original position. ಆಮೇಲೆ it goes to the yield point. So OC is nothing but yield point. Yield point in the sense body ತನ್ನ elastic property ಕಳ್ಕೊಂಡ್ಬಿಟ್ಟಿದೆ ಬಟ್ ಬ್ರೇಕ್ ಆಗಿಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಇನ್ನೂ ಸ್ವಲ್ಪ ನಾನು ಸ್ಟ್ರೆಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಅಥವಾ ಇನ್ನೂ ಸ್ವಲ್ಪ ನಾನು ಫೋರ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಇಟ್ ಗೋಸ್ ಇನ್ ಟು OD, ದಟ್ ಈಸ್ ultimate strength. So it has reached its maximum strength. If I take OE will be my breaking point. So OE will be my breaking point. So this is nothing but the stress strain curve that will be asked in your some points is very very important. Based upon this, some properties also given here. So in the next class we will be moving with some in the moment of inertia, center of gravity and all, and with some SFD BMDs also, and also we shall see some how the questions will be appearing in the examination sections. So thank you guys.